Okay, here we go. We are going to do an example of variation of parameters. I spent the last couple of videos working out a formula. Is it here? Yep, it's right here. XP, there should be a line over top of that, a vector sign, but whatever. XP is x times the integral of x inverse times f of t. This is the system that we've been working with all along. So this should be familiar. A is -3, 2, 3, -4. My input, my monkey, my force, whatever you want to think about it as, right here, is 4e to the negative t with a 0 there. I could, this right here is the problem. I could also write it in this form. This is exactly the same as what I have here. -3x plus 2y plus that term, and then this guy plus nothing. So, what work have we done already? Well, we had the matrix A, we did the characteristic equation, got the eigenvalues, used those to get the eigenvectors, and this would be the XC. This would be the fundamental matrix. That's this big X that I'm going to use here, and then I'm going to invert there. One thing I want to point out before we go through this long process, because it's pretty long, is I want you to think intuitively about this. I've got this. What are like the roots of this equation? They're that negative e to the negative t and the e to the negative 60. Those are these pieces, right? I need to have my solution be that plus something that will, quote, pump this out, that will pump that out. Now, what would you have done with undetermined coefficients if I had given you this? Well, you would have chosen an e to the negative t. But, look, if I were to do a1, a2, e to the negative t, then it feels like this thing right here, right? So where are we? We're in a repeated root scenario. Now, I'd like you to think back to repeated roots earlier. What did we do? We tacked a t on, right? And you may think, oh, let me just do undetermined coefficients with a t tacked on. Nah, doesn't work like that. But a t does sort of show up. Well, it doesn't show. It shows up. And it's sort of magical how this formula right here pumps out what we intuitively talked about in the first semester for so long about tacking t's on and linear independence and blah, 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 blah. So, hopefully you understand the formula, you see all this work, you understand all that work, and you intuitively say, well, we've got a repeated root, and we got to do something about that, because this guy here can't match that guy. Anyway, here we go. Let's do the rest of it. Okay, so I have a whole lot I got to do here, and I'm going to break it down into steps. First thing I'm going to do is find this. Then I'm going to find this product. Then I'm going to find the integral. And then I'm going to do my last step of multiplying. So, x inverse. Remember, so I've got x listed right there. A, B, C, D inverse is 1 over the det, that is AD minus BC, times, switch the A and the D, dA, and then negate the other two, minus B minus C. So, I said this when we originally did it, but I can do this on things that are functions. So I can use this formula right here to find the inverse of this matrix. That is wildly convenient, because otherwise trying to find the inverse of this matrix would be a lot of work. It's possible to do it without it, but you'll get the same thing. So, let's see if we can do it. Oops. X inverse is, all right, 1 over, what's the det? Or it's, let's see, it's e to the negative t times negative, I'll put it out front, 3e to the negative 6t, correct? Yep. Minus 2e to the negative 6t. That is, the first one was this times that. It's this. Now I'm going to go this times that, but negative. So minus 2 e to the negative 6t times e to the negative t times. All right, DNA switch. So I get negative 3 e to the negative 6t, e to the negative t, and then I get negate the other two, negative 2e to the negative 6t, and negative e to the negative t. Cool. So from here, I get, so I want to point out a couple of things. One, I got an e to the negative t and an e to the negative 6t. E to the negative 6t, e to the negative t. Those guys are going to give me the same thing. So this and this are actually like terms. This one has a negative 3, this one has a negative 2. So I'm going to write this as negative 1 over 5 times 1 over, if I multiply this by that, I get, by exponent rules, e to the negative 7t. Same thing here. So times e to the negative 7t. Open parentheses. That thing here stays the same. I'm not going to rewrite it right now. Maybe I will. There, I can copy it. So from here, I get equals. I'm going to kind of like try to find the easiest path through all this. First thing I see is that there's a negative here, here, and here. And there is not one there. It kind of annoys me. I would normally just leave it, but I recognize I got a negative there. So I could distribute this negative into all these pieces and write this as a positive 1 over 5. I'll change those signs in a moment. Times, look at this right here, e to the negative 7t. It's in the denominator. I'm going to pop it to the top and write e to the positive 7t. Now I'm going to get my 3e to the negative 6t, 2e to the negative 6t, positive e to the negative t, and then this one gets negated, e to the negative t. Now let me repeat. I took this negative, applied it in all there. That's why this, and this are positive, and this is negative, and I flipped this up to the top. So next step is 1 over 5. I'm going to distribute this into each of these pieces. So what I wind up getting is, open parentheses, do I want to write it out? I'm not going to write it out fully. Look, this gets multiplied in by that. E to the 7t times e to the negative 6t. Well, the 3 stays, but I'm left with the e to the positive t. Why is that? Because it's e to the negative, it's e to the 7t times e to the negative 6t, which is exponent rules, e to the 7t times, plus a negative 6t. We add there, and that gives me a e to the t after I do 7t minus 6t. That should be okay. Okay, so I also get a positive 2 e to the positive t, and I get this one gives me a e to the 6t, and then this one gives me a negative e to the 6t. Okay, so I think that this is my x inverse. Now what I need to do is do that part in there, which is x inverse times f of t. So I'm going to slide over and write that in another open space. So x inverse f of t is going to give me 1 over 5, open parentheses, 3e to the t, 2e to the t, e to the 6t, negative e to the 6t, times it was 4e to the negative t, 0. Okay, so that is 1 over 5. So remember, when I multiply, I go across and down, across and down. This gives me, I will write this one all the way out, 3e to the t times 4e to the negative t, plus the next product is going to give me 0. And then I get e to the 6t times 4e to the negative t, plus the next product is going to be 0. So that gives me 1 over 5, open parentheses. Actually, am I gonna do that here? Yep, I am. I am going to recognize that there is a 4 in both terms, so I'm going to just put a 4 out there. And then I'm going to be left with just a 3 and a e to the 5t, is that correct? Yep. What I did here was I said I just really like to get rid of mess if I can, and I'd rather just get this stuff out here and move it out of the way and have it as a scalar and not write it 2 times. I got a 4 and a 4, so I pulled the 4s out, and then what I do next, I multiplied e to the t by e to the negative t. That canceled out to give me just 1, so I have the 3, and then e to the 6t times e to the negative t, that goes to a 5. So this is x inverse times f of t. And I'm going to go back up top. So my next layer is going to be, you can see here, I need to integrate that. So here we go. Going to do that integral. It is the integral of, I got it here. It is the integral of, 4 over 5. Sorry, I thought I was going to have to copy more complicated stuff down, but 4 over 5 times 3 and then e to the 5t, which that gives me 4 over 5 stays there. I think I said all this stuff as I was doing it. I'm losing track of what I'm doing. Anyway, ba-doop, it's this integral. So that is the integral of, what the integral of 3 is 3t, and the integral of the e to the 5t is 1 over 5 e to the 5t. Now this is in a form that I really do not like. I do not like those fractions inside of my matrix. So I'm going to pull an extra 5 out, and that gives me 4 over 25, open parentheses. I actually wound up getting a 15t and a e to the 5t like that. You may say, what? And I don't know why I changed colors there, but if I were to take one of the 5s out of this 25 and divide it into there, I would be left with that. And one of the 5s out of this 25, I would divide it into here. I'd be left with that, and I would be left with 1 5 out front. So yes, it is the same thing. So my next step is so if I go back over here, I've got this. That is what I have over there. All I got to do is multiply it by x on the left side. So come back here. I'll do this in black. So I need to do x times the integral of x inverse f of t dt. Well, that is what was x? It was e to the negative t, e to the negative t, and then 2e to the negative 6t, and negative 3e to the negative 6t. times, I'm going to make some space here to write my 4/5 there. I can move that piece around, times 3t, and then, 15t, and then e to the 5t. You might sort of see where this is going. It's sort of magical the way this works out. I just got to do some multiplication here. And I get 4/5. Going to leave that out front. All right. So, why did I write 4/5? 25. Okay. Now we're cool. All right. So, this gets multiplied by that. And then this gets multiplied by that. So I will write that out. I get e to the negative t times 15t plus 2e to the negative 6t times e to the 5t. In the bottom, I get e to the negative t times 15t again plus, minus 3e to the negative 6t times e to the 5t. Some exponent work. This gives me 4/25 times, I'm going to write it as 15t e to the negative t, 15t e to the negative t. And then I get this This multiplication here, again, exponents, negative 6t, 5t. What's that give me? It gives me an e to the negative t. So it kind of gives us what we should expect, plus 2e to the negative t minus 3e to the negative t. Now, so it's kind of crazy how this worked out. Think about it. I wrote a bunch of stuff here. Here's my xp. Here's my xc. Here's the problem we're solving. X prime equals ax plus this thing, right? Remember, the c solution, the solution that has my c's in it, has an e to the negative t in it. So does my monkey. When I apply a force that matches this, we learned way early that we had to tack t's on, right? Well, look at what happened here. I get an xp using this formula that has these pieces, which are e to the negative t's. Notice the 2 and the 3 are linearly independent from the 1 and the 1. So this does not get soaked up into the c's when I do xc plus xp. And this thing, this t, it just showed up based on how the math worked out. I got this 15t. It multiplied in. Boom, 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 boom. What do I get? I get that t tacked on that we would have intuitively tried to put on. And boom, I got my answer. One thing I'll comment, there are some patterns here that you might see that sort of line up with this. And the more that you do this, the more that you'll see them. Some of those patterns only fit with this repeated root piece. And for other things, those patterns don't exist. I will warn you, integration by parts comes up in these a lot when I'm doing, is it this step? Nope. This step up here. This integral right here. A lot of times I get a e to the 5t times a cosine t. What do you do then? You got to integrate by parts. Or I get a t e to the 5t or something like that. So be ready to do integration by parts on this. I think that the integral work, this is a lot of work. I'm not going to lie. That's a whole lot of math. But it's pretty straightforward. It's just multiplication. The most difficult part for most of these, besides not messing up your basic math, and you know who I'm talking to, right? Let's be honest, but you know who I'm talking to. Anyway, this multiplies through, and this integral can sometimes be a mess. So anyway, you have to deal with that. But there you go. That is variation of parameters, and I hope that you understand it, and I will give you some practice. See y'all. Hope you're doing well. Bye.